Okay, so after going through all that trouble but 5 times, one for each of these trials that I mentioned before, let's have a look. So we have one capacitor, one resistor, and if you teach Physics C, or if you're an electrical engineer, or if you understand really what's going on with these RC circuits, please be very careful about talking about this time constant thing. If you know what I'm saying, I wouldn't talk about that with your students. What I would do is I would talk about the time it takes to cut the voltage in half. So for example, I started taking data at 1 every single time. So every single trial, I took data as soon as the voltmeter read 1. And then, how much time does it take to get to half of that? Well, here, it takes 60 seconds to get to half of that. What's funny is that it takes 60 seconds no matter where you start to get to half. What do you mean? Well, 0.8, what's half of 0.8 is 0.4. That's 60 seconds as well. Okay, what about 0.4 to 0.2? That's also 60 seconds. This is a great opportunity to front load the idea of half-life on your kids. You may want to use this as an opportunity to talk about half-life. You may not say the word half-life. I would call it halving time, the time to go half. But when you teach half-life, at least they saw something like this before. Here's one capacitor, 2 series with resistors. What I noticed is that the halving time actually doubled. So double the resistance is double the halving time. So the halving time is directly proportional to the resistance. That was double the halving time. But one capacitor, 2 parallel resistors, that's half the resistance. And it results in half the halving time. Here's 0.5, and it took about 30 seconds to halve. And then from there to 60, that would be 0.5 to 0.25, halved again. 30 seconds to halve every time. So half the resistance, half the halving time. Okay, 2 series capacitors does the same thing as 2 parallel resistors. In other words, half the resistance is the same as half the capacitance, half the time to halve. Yeah. You know, let's get Karl Marx in here talking about haves and have-nots, right? Let's just make all kind of puns there. Parallel capacitors do the same as series resistors. They double the time it takes to cut in half, which means that parallel capacitors act like a doubled capacitance. So, conclusions I would want my kids to draw. The halving time for discharge is directly proportional to the resistance and directly proportional to the capacitance. And the capacitors in parallel make a greater equivalent capacitance. Less equivalent capacitance comes from capacitors in series. So, is it worth all the time? You got to make that decision. But I would want students to see all this and to experiment with it. All right, I'll see you all in the next module, magnetism.